Hello, and welcome to Back to Farm on ARCN TV. My name is Joshua Ishaya, your host on the program Back to Farm. On this episode of the program, we'll be looking at something farmers don't pay attention to before embarking on any agricultural production, which is soil testing and pre-season planning in agriculture. Understanding your soil is crucial for successful farming. Some tests offers valuable information that can shape your pre-season planning. Farmers can make informed decisions to optimize crop yields and soil health by identifying nutrient levels, potential issues, and biological bottlenecks. Pre-season planning is essential to farming as it helps farmers prepare for the upcoming growing season and optimize crop yields. A critical aspect of pre-season planning is soil testing, which involves collecting and analyzing soil samples to understand the soil's nutrient availability and overall health. Farmers need to conduct soil tests before planting. Today we will explore why soil testing and pre-season planning is crucial, the advantages of a biological soil test, and tips for conducting one. You will learn how to select a reliable laboratory, use proper sampling techniques, and utilize the results. When farmers understand the soil more thoroughly, they can improve their harvest. Stay tuned and take a look.
Soil testing. Soil testing is a process of determining the chemical, physical, and biological composition of soil which allows it to be properly understood and used for crop production. Soil testing allows us to determine the level of nutrients such as phosphorus, potassium, nitrogen, and magnesium, as well as the pH of the soil and its water content. With this information, it is possible to accurately adjust fertilization and select the right plants for the area. Soil testing methods can vary depending on the purpose of the test and the type of soil, but mostly common use methods are laboratory analysis of soil samples, which involve taking soil samples from different layers and analyzing them chemically in a laboratory. Number 2, generally soil evaluation, which involve direct observation and evaluating soil properties such as color, texture, organic content, and moisture content. Field testing, which involves growing plants and monitoring their growth and development to determine soil nutrient levels. It is important to remember that soil testing should be done regularly, especially before planting a new crop, as soil changes can occur throughout the year. The result of the soil testing should be interpreted by specialists who will be able to advise on what measures should be taken to improve soil quality and increase yields. In conclusion, we will say soil testing is essential for successful crop cultivation. Through regular testing, it is possible to know the composition of the soil and the level of nutrients. Soil testing is a key part of plants planting and cultivation. Soil is the lifeblood of plants, providing them with nutrients, water, and oxygen. However, in order for soil to be used effectively for crop production, a proper understanding of the soil is essential. And the composition of the soil allows you to accurately adjust fertilization and select the right plants for the site. This documentary is a comprehensive guide to soil testing, so you will learn everything you need to know to correctly interpret test results and take effective action to improve soil quality. We'll introduce you to soil testing methods, tell you about soil components and their role, and show you how to interpret test results and what action to take to improve the soil quality of a site. By watching this documentary, you will not only learn the basics of soil testing, but you will also learn how to put this knowledge into practice. Why is soil test important? Soil testing is important because soil is the livelihood of plants, and a proper understanding of soil allows it to use effectively for crop production. The first and most important reason why soil testing is important is that it allows you to determine the level of nutrients such as phosphorus, potassium, nitrogen, and magnesium, as well as the pH. Another important reason is that soil testing makes it possible to detect and solve problems. It is important to remember soil testing should be done regularly, especially before planting a new crop, as soil changes can occur throughout the year. The result of soil testing should be interpreted by specialists who will be able to advise on what measures should be taken to improve soil quality and increase yield. Soil testing is important for environmental protection. By improving the quality of soil, water retention can be increased and the soil's ability to absorb water can be enhanced, which contributes to climate protection. Soil testing is important for increasing yield, solving soil problems, and protecting the environment. It is a key part of the crop planting and cultivation. So it is important to conduct regular soil testing and take appropriate action based on the result. Preparing for soil testing. Preparing for soil test is a process that involves proper site preparation and soil sampling to ensure reliable and accurate test results. Before conducting a soil test, it is important to think carefully about the purpose and scope of the test. These will allow you to determine the appropriate testing methods and determine which soil component should be tested. It is also necessary to determine what crop is being grown, what its needs are, which will help determine the required level of soil nutrients. Another important step is site preparation. Make sure that soil sampling is done on plots that are representative of the site. Samples should be taken from different soil layers as recommended by specialists, since the soil components can vary at different depths. When taking sample, it's important to follow proper procedures, such as using clean tools and containers and storing samples properly. Soil samples should be transported and stored properly to avoid contamination or changes in composition. The final step is to send the samples to the laboratory and wait for the test result. Before sending the samples, make sure they are properly identified and protected from contamination. It is also a good idea to determine whether the results will be available by email or by carrier. How to develop a soil sampling map. Developing a soil sampling map is an important part of planning and conducting soil survey. A soil sampling map allows you to determine where and what soil samples should be taken, allowing you to obtain reliable and accurate test results. It is worth noting that such functionality will soon be available in the MeteorTrack Agro application. To develop a soil sampling map, perform the following steps. Find the purpose and scope of the soil survey. This will determine what soil components should be tested and where soil samples should be taken. Define the area to be surveyed. This can be the entire growing area, some parts of it, or different fields on a map. Develop a sampling map. This allows you to determine how many and what soil samples should be taken and where they should be taken. In agriculture, the determination of sampling maps will be done automatically using two methods, such as the north-south method and the based on the NDVI index. The north-south method involves sampling soil according to the north-south direction in a given area. This method produces representative soil samples throughout the study area, and samples are taken evenly throughout the area. The second method is a determined sampling map based on the index. Index is an indicator of plant health and help determine which areas are best used and which need improvement. In agro application, these two methods allow for efficient and automatic determination of soil sampling maps, which allow for reliable and accurate soil results. With the agro app preparing for soil testing will be much faster and more accurate. How to interpret soil test results. Interpreting soil test result is an important part of the soil testing process, and it allows you to understand the coordination of the soil and its needs and to take appropriate action. Soil test results contain information on nutrients, soil pH, water abundance, the presence of pathogens, and other important factors affecting plant growth. To interpret soil test results, it is necessary to analyze each soil component separately. The level of nutrients such as phosphorus, potassium, nitrogen, and magnesium is particularly important. The optimal level of this nutrient varies for different plants, so it is important to know exactly what a plant needs and compare it to the nutrient level in the soil. Soil pH is another important factor. The optimal pH level also varies for different plants, but in general, soil with a pH between 6 to 7.5 are suitable for most plants. If the pH of the soil is too low or too high, there may be problems with plant growth, and appropriate measures such as changing fertilization should be taken to improve the pH level. Soil water richness is another important factor. Soil with adequate water content allow plants to develop properly, while soil with low water content can lead to problems with plants' development. The presence of soil pathogens and disease is an important element to consider when interpreting soil test results. Pathogens are microorganisms such as bacteria, fungi, and viruses that can affect plant development. Soil disease are symptoms caused by pathogens, which can manifest as spots, rotting roots, lack of plant growth, etc. If soil test results show the presence of pathogens or soil disease, it is important to take appropriate measures to control them. These may include the use of fungicides or other chemicals, the use of natural control methods such as the use of predators or the use of methods related to crop rotation. It is also important to remember preventive measures such as proper fertilization and soil care to maintain soil health and protect plants from pathogens and diseases. Now, let's look at the most common mistakes in soil testing. Soil testing is an important part of planning and carrying out cultivation, as it allows to determine the condition of the soil and its needs and to take appropriate action. But unfortunately, many people make mistakes during soil testing, which can lead to incorrect results and difficulties in making crop decisions. Here are the most common mistakes people make during soil testing. Improper soil sampling, taking soil samples from the wrong location or on the wrong way can lead to incorrect test results. Improper storage of soil samples. If soil samples are not stored properly, they may be altered and will not represent the true condition of the soil. Incorrect determination of the sampling map. This is one of the most significant mistakes that are made. If the soil sampling map is not properly delineated, soil samples may be taken from unrepresentative locations. Incorrect interpretation of test results. If soil test results are not interpreted correctly, these can lead to incorrect crop decision. Neglecting prevention. Conducting soil tests only at the time of plant problem is too late, and attention should be paid to preventive measures such as proper fertilization and soil care. Soil testing is an important part of planning and carrying out cultivation and allows to determine the condition of the soil. Soil testing is also a cost-effective way to inform fertilization and other management decisions, as it helps farmers avoid applying unnecessary input that could be detrimental to soil health. Rather than blindly applying fertilizer, farmers can use testing results to determine which nutrients are lacking and apply the appropriate fertilizer in the right amount. This helps reduce the risk of over or under fertilizing, which can harm soil health and plant growth. How to conduct a soil test. Follow this step to ensure accurate results and make the most of your presentation plan. Pre-season planning for more detailed steps on how to collect soil samples. Select a reliable laboratory. The accuracy of results depends on the laboratory's analysis, so choose wisely. Number 2. Proper sampling procedures. Collect representative soil samples, ensuring accurate reflection of soil health. Use recommended tools and follow sanitization guidelines. Shipping and storage. Follow proper storage and shipping guidelines to preserve soil samples integrity. A soil test is relatively simple, but farmers should observe proper sampling procedures to ensure accurate results. The first step is to select a reliable testing laboratory. Next, farmers will need to collect soil samples from the field. At biomakers, you provide sampling tubes and spoons. The amount of soil necessary is approximately 1.5 of the tube, about 5 grams per sample. No additional equipment is required to collect soil samples, though we strongly suggest wearing gloves to protect your hands. Before and after taking each sample, it is essential to sanitize your trowels with ethanol and let it fully dry before continuing. This helps prevent contamination and ensure accurate results. Ideally, samples should arrive at the lab within 72 hours from the time they are collected. However, we have not observed significant changes in the microbial communities for up to 15 days after sampling. Given that soil microbiomes are sensitive, these are the recommended guidelines for proper storage and shipping. Soil samples can be stored long time at -20 degrees centigrade. Soil samples can be stored for up to 3 days if refrigerated at 0.6 degrees centigrade. Optimum shipping for soil samples should be within 1 day, with the maximum transit time of 5 days at room temperature. Once the soil samples are collected, They should be labeled appropriately and sent to the testing laboratory for analysis. Soil tests vary from basic tests and measure nitrogen, phosphorus, and potassium level to comprehensive tests that measure nutrient cycling, biodiversity, and microorganism levels. Tests available for specific issues might include soil pH or salinity, as well as chemical, physical, and biological analysis. Traditional soil analysis provide information about the physical properties and the chemical properties of the soil, such as pH or concentration of nutrients, but do not take soil microbiology into account. Instead of measuring the amount of nutrients in the soil, biomakers test measures the microbial process involved in nutrient cycling, such as those that fix carbon into the soil, supply plants with available nutrient forms, and those that immobilize nutrient back into forms not readily available for plants, and denitrification. Now, let's talk about how to interpret soil tests. Once the soil test results are received, it is time for farmers to carefully review and interpret the data to understand what the results mean for the fields. The results will typically include information on the level of various nutrients in the soil, plus the pH and potential problems such as compaction or poor drainage. Farmers can pay attention to blocked nutrient cycling pathways and disease risks, both of which impact plant growth. For example, a specific blocked nutrient pathway may limit plant growth, while an excess of the same nutrient could potentially be toxic to plants. Now, let's look at some of the methods in land preparation. Manual method. Due to its accessibility to practical everyone and low to no financial outlay, this type of land preparation is the most popular. These manual methods include weeding with hoes, coating with a cutlass, and clearing the field and waste by hand picking. Chemical method. Mechanized method involve removing the current vegetation using machines like bulldozers, graders, tractor plows, and more. This is usually used on large properties or in dense forest area where manual method might not be effective. Chemical methods. These involve using herbicides to eradicate the current vegetation or weed on the land. However, it is not frequently used because of the fear that these chemicals might deplete the soil's nutrients or create more detrimental conditions for the environment. Steps to follow in land preparation. In order to guarantee the crop are well established after land is prepared, it is important to carefully choose the most suitable approach. This means that not allowing the proper steps can cause harm to the ecosystem, affecting both water and land resources. Environmental consequences are regarded as a primary issue when detailing land preparation procedures. You have to put the effect it will have on the environment into consideration when preparing the land for usage. There are various steps when preparing the land, and a few of them are pre-irrigation. This is the first step in land preparation. Pre-irrigation is regarded as the practice of flooding the field for a maximum of 3 days before the initial tilling in order to wet and loosen tight and compacted soil for plowing to make easier tilling. The next activity after pre-irrigation and land preparation is clearing the field or site, which is also referred to as tilling. This will ensure that any undesired vegetation, such as weed, is eradicated. This is done to clear the way for the new plantation that will be planted on the land. Avoid unwanted competition with new plants and remove any weeds that may be a problem for the crop. These must be carried out carefully and intelligently in order to guarantee that the undesired vegetation is removed from the roots, avoiding any future complications and impeding the proposed crop that will be grown in the area. Harrowing. Harrowing, which is also referred to as secondary plowing in land preparation, will help break the clumps of dirt into the tiny beads. Harrowing often results in a well-aerated soil for cultivation. It also helps achieve good soil moisture, which will make it easy to work on the soil and paving the way for the critical plant and life requirements such as nutrients. When a soil sample is taken after a recent lime application or within a year after a heavy lime application, there will still be a certain amount of unreacted lime in the soil. In this situation, the amount of Ca and management extraction from the soil will be partially from extensites and partially from dissolved lime. It is calculated using these Gaussian levels will be erroneously high since the CA and the management are not derived entirely from exchange size. To correct for this situation, an additional baryon absorption test is performed on all high pH soil, which isolates corrects these samples. The correction is made by adjusting the milliequivalent levels of soil sample is coned in the center of mixing sheet. Cone is flattened and divided through the center with a flat wooden sheet. One half is moved to the side quantitatively, then each half is further divided into half. The four quarters being separated into separate quarters, two diagonal opposite quarters are discarded quantitatively. The two other are mixed by rolling. This process is repeated until 250 to 500 composite soil material is obtained. For micronutrient analysis, sampling and processing of samples should alone be done only with the stainless steel materials, plastic or wood, to avoid contamination. The soil test values, calibrated nutrient functions are advocated to the farmers as a package of nutrient management that aims at judicious use of fertilizers. Ultimately, any soil testing and interpretation must involve economics because it's used to make a fertilizer recommendation to achieve an economic goal that will give maximum profit per hectare of land. Many chemical extractants have been developed for use in soil testing. The ability of an extractant is to extract a plant nutrient in quantities related to plant requirements depends on the reaction that control nutrient supply and availability. The extractants commonly used in soil testing programs are given. Soil testing laboratory of Department of Agriculture are usually functioning at identified centers in each district. Soil testing services are also extended to farming community in the soil laboratories operated. Let's look at the major function of soil testing laboratories. Analysis of soil samples which are collected from farmers by the assistant agriculture officers textures, lime status, electrical conductivity, analyzing irrigation water samples, forecasting and anions, assessing their quality based on different parameters and suggesting suitable ameliorative measures for different soil conditions and crops, adopting to village for a particular period by each soil testing laboratory, collecting and irrigation water samples at free of cost and advocating recommendations. The mineral components of soil are sand, silt, and clay, and their relative proportion determine the soil texture properties that are influenced by soil textures include porosity, permeability, infiltration, shrink well, rainwater holding capacity, and susceptibility to erosion. In the illustrated textual clarification triangle, the only soil in which neither sand, silt, nor clay predominate is called loam, while even pure sand, silt, or clay may be considered as a soil from the perspective of conventional agriculture. A loam soil with a small amount of organic materials is considered ideal, inasmuch as fertilizers or manure are currently used to mitigate nutrient losses due to crop yields in the long term. The mineral constituents of a loam soil might be 40% and 40% silt and balance 20% clay by weight. Some texture affect soil behavior, in particular its retention capacity of nutrients, exchange capacity of water. Sand and silt are the product of physical and chemical weathering of the parent rock. Clay, on the other hand, is most often the product of the precipitation of the dissolved parent rock as a secondary mineral, except when derived from the weathering of mica. It is the surface area to volume ratio of soil particles and the unbalanced ionic electric charges within those that determine their role in the fertility of soil. Measured by its cation exchange capacity, sand is least active, having the least specific surface area, followed by silt. Clay is the most active. Sand's greatest benefit to soil is that it resists compaction and increases soil porosity. Although these properties stand only for pure sand, not for sand mixed with smaller minerals, which will fill the voids among sand grains. Silt is mineralogically like sand, but with its higher specific surface area.
It is more chemically and physically active than sand, but it is clear content of soil. With its very high specific surface area and generally large number of negative charges, that gives the soil its high retention capacity for water and nutrients. Clay soil also resists winds and water erosion better than silty and sandy soil.
Soil testing during farming pre-season planning facilitates a deeper understanding of soil nutrients levels and overall health. A soil test can identify and address any potential problem with the ground, such as nutrient deficiencies or imbalances before planting. Soil testing can also be a cost-effective way to inform fertilization and other crop management decisions by leveraging on data results to optimize crop yields and soil health. Farmers can help ensure the field's long-term productivity for years to come. On that note, we come to the end of this episode of the program where we explained the importance of soil testing before embarking on any agricultural production. Many thanks for staying through on the program Back to Farm. My name remains Joshua Shah.